Alright, so welcome to the third video. This time I'm going to start the second mechanics problem sheet. So I'm going to start with the first question, is a horse pulling the carriage? So I'm just going to draw what the problem's indicating here. So a horse is pulling a carriage that weighs 500 newtons. Alright, so here's my carriage. This weighs 500 kilograms. Alright, attached, and there's a horse that's pulling it. So let me just draw my little horse. Anyways. Alright. The attached behind the carriage is a small sleigh weighing 200 kilograms. Alright. So that's 200 kilograms. What is the force required to pull these two attachments at a constant velocity if the coefficient of friction is 0.4? Alright. So before I get into talking about the problem and how to solve it, I want to talk about what it means constant velocity. So if the velocity of an object is not changing, does it have an acceleration? Alright? Hopefully you all answered no. If an object has the same velocity, it always has no acceleration. So acceleration means a change in velocity, and if the velocity is therefore not changing, then the acceleration is zero. And because force is equal to mass times acceleration, then mass times an acceleration of 0 gives you a force of 0. So when an object is neither accelerating or decelerating, then all the forces are in balance. There are no forces that are out of balance, and therefore the horse is not, or not in this case is the horse, but the object is not changing velocities. Now that doesn't mean that the object is not moving. The object is moving, just not changing velocities, and that's what the force affects. The force increases or decreases something's velocity. I hope you guys understand that. If you don't hesitate to ask me. So here we go. We have this thing that's going, this horse that's going in this direction, and I want to draw my free body diagram. Here we have to deal with a whole bunch of tensions, and I'm going to explain to you how the tensions equal out. So before I do that, I'm going to talk about gravity. So I'm going to call this Fg1, and this one Fg2. This one up here is Fn1, and this one here is Fn2. Alright, there's a force of friction going this way. I'm going to call this force of friction 2, and I'm going to call this one, I'm going to write it up here just so it doesn't overlap with my tension, force of friction 1. And so this here is the tension here. So there's a tension there, there's a tension here, there's a tension here, and there's a tension here. Alright? Now these tensions, they actually don't really matter. What really matters is the horse pulling. Alright? And the reason for that is, if I didn't have this rope in the middle and this rope here, and they were both all attached to the horse, then it would be the same thing. The horse is still pulling the same amount of weight, if not maybe less, if you consider that the rope weighed something. Right? So in fact, the rope doesn't actually change anything, and the tensions therefore all cancel each other out. Alright? So really the only force that are acting on this is the force applied, that's an A, the force applied acting against the two forces of friction. Alright? So if I'm saying that the velocity is constant, that means the force applied has to equal to the sum of the two forces of friction. Alright? Now, let's do this the long way, and then hopefully by now you would have figured out the short way, but let's do it the long way. So here's my object, well, I'll do object 2 because it's closer to 2, and this is going to be object 1, which is this one here. So I have the force of gravity, I have the force of gravity, I have the force of the normal, I have the force of the normal, I have the force applied, I have the force of friction. This is the force of friction 2, and this is the force of friction 1. And I know that all my forces are 0 because I said that it's going at a constant velocity. Alright, now let's do my zeros. I know that this is a 0, this is a 0, this is a 0, this is a 0. Same thing here. I know that this is going to be negative, this is going to be positive, this is going to be positive, and this is going to be negative. This is going to be negative, positive, positive, negative. And so here, FG2 is 200 times 9.8. So I'm not going to bother writing that long. I'm just going to write 200 times 9.8 in my calculator. And that's 1,960 newtons. The normal force is therefore also at 1,960 newtons. And therefore the force of friction is 0.4. 0.4, and I wrote that here, is the coefficient of friction. 0.4 times the normal force, which is negative 784 newtons. Alright? And therefore, my force applied, if I want to get this to be 0, is 784 newtons. Alright? Now the same thing can be done here, so let's do it. 500 times 9.8. This is 4,900 newtons. And therefore this is positive 4,900 newtons. My force of friction is 0.4, which is my coefficient of friction, times the normal force. And that's equal to 1,960 newtons. And therefore, if I want to have an overall force of 0, I have 1,960 newtons. Alright? Now, my horse has to overcome these two forces of friction by applying these forces, so my total force is equal to F1 plus F2, or FA1 plus FA2. The first force applied plus the second force applied, which is 784 newtons plus 1,960 newtons. Alright, and that equals to 2,744 newtons. So my horse needs to apply 2,744 newtons if he is going to keep this carriage and sleigh going at a constant velocity. Alright? Now if I were tricky and I wanted to ask you for acceleration, I didn't here, but let's say I did ask you for acceleration, you would divide it by the mass of everything together. So you would do force is equal to mass times acceleration, and the force is equal to 2,744, and the mass is equal to 700 kilograms times acceleration. Right? I'll let you solve for that if you're interested in it. Alright, so that was number 1 on the second problem sheet. Alright? Alright, number 2. A brick wall can withstand 200,000 newtons. That's a lot of newtons. That's a lot of force. A car that weighs 2,000 kilograms comes crashing down the road, so it comes crashing down here and collides with the brick wall, which takes the speed of the car from 200 kilometers an hour, which is equal to 61.1 meters per second, all the way to, and as soon as it crashes, 0 meters per second. Alright, so because it stops, right? It hits a wall and it stops. That's the whole point. Now it does this fast deceleration in 0.4 seconds. Alright, so therefore the acceleration is equal to the final velocity, so 0 minus 61.1 meters per second divided by 0.4. That's a huge acceleration. Is equal to negative 152.75 meters per second squared. Alright, now if my truck weighs, or my car in this case, weighs 2,000 kilograms, force is equal to mass times acceleration. And therefore, 2,000 kilograms times 152.75 meters per second squared and that's equal to 152.75. And that's equal to 305,500 newtons. All right? All right, so when this car crashes into the wall, it applies to the wall 305,000 newtons. Now you just have to see, is this more than the 200,000 threshold? Yes, it's way more. So you're definitely going to bust the wall. The wall is ruined. And that's it for number 2. Number 3, the one with the pinball, we're not going to do that one. I'll save that one for after Christmas. Number 4, we will do them. So here it says that there's a car stuck in the snow. The car weighs 1,500 kilograms. And you and your friend push it. Okay, I'm going to put you guys together so that there's a force applied, there's just a force of push. And the engine is also putting some force in, so I'm going to write Fe for the engine. And that's also trying to make it go forward. The force of friction is making it difficult to push. It's got a normal force. It's got a gravity force. All right? The force of the engine is 6,000 newtons times 0.1. That's the 10% that I talked about in the question. And that's therefore equal to 600 newtons. So the engine's only capable of putting in 600 newtons of force. Me writing that it was 6,000 was to give you an idea of how much force is lost when your car is stuck on an ice patch or something like that. All right, so you get not a lot of force when it's that slippery. So the engine is applying 600 newtons. Let's do my X and Y table. And we have a few more forces this time. And again, this question is asking us to find the force required to move the car, to just move the car, right? So we need to figure out what do we need in order to get just more than zero newtons of a total force. So I need to know just what can I do to make it go just above 0 newtons. So essentially I'm solving for 0 newtons. And then I'll just have to up that up by a little bit. Alright, so here are my forces: the force of gravity, the force of the normal, the force of friction, the force applied by you and your friend, and then the force of the engine. Alright, so the force of gravity has no this. These ones have no y. This is going to be negative, this is going to be positive, negative, positive, positive. And this is going to be mass times acceleration. So F equals m times g. So mass is 1500 times 9.8. This is equal to 14,700 newtons in the negative direction. So therefore this is going to be 14,700 newtons in the positive direction. It says in the question that the coefficient of friction is 0.3. So this is 0.3 times the 14,000 normal force. So 0.3 times 14,700, and that's equal to 4,110 newtons. All right, the engine supplies 600 newtons, and obviously this is in the negative direction. So now what you and your friend need to do is overcome this friction using the help of the engine. All right, so you have to figure out that this force of friction, which is negative, plus your force applied, plus your force of the engine should give you 0. All right, so I'm going to write that here. Minus 4,410 plus 600 plus x is equal to 0. And therefore your x is equal to 3,810 newtons. All right? That means you and your friend need to exert at least 3,810 newtons in order to make this car move. All right? Good luck. That's a lot of newtons. Does that make sense? So it's at least 3,810 newtons. That's to overcome the friction with the help of the engine. As long as you can get just above that, you can get the car to move. Number 5, we're not going to do. All right, so that's it. I hope these videos helped. I know it's a bit messier than usual, but I'm trying to get as much stuff as I can get done before the exam, and my handwriting had to have taken a hit. So I hope it helps. If there are any questions, please let me know. Thank you.